Okay, today we are talking about section 3.4, which is systems of equations in three variables. So keep in mind, since we have three variables, we're basically talking about three dimensions, which means that the answer, the solution to a system in three variables, is not going to be an ordered pair, but an ordered triple. And we write that x comma y comma z. Okay, now think about the different cases and what it's possible. I think it's helpful to get a visual on that. So think about each of these cases and how many solutions you have. Remember, if it's three dimensions and we're talking about a plane, so one case could be that the three planes intersect in a line, in which case how many solutions we have, of course, is infinitely many. Or they could intersect as such. So how many solutions do they have? We're looking for the points where all three planes come together. So in this case, we would have none. In this case, I could have three different names for the same plane. So again, it would be I can't spell, because I don't have anybody here telling me how. Um, Infinitely many, because each time, again, I'm just asking how many solutions we have. All right, then I have another case down here where the planes could look like this. How many solutions do we have? Again, none, because there's not anywhere that all three of them come together. Then I have this situation right here where I could have one point of intersection. Okay, and then the last one would be, again, if they don't intersect and they're all parallel, um, again, none. So the different possibilities that we have should help you as you write your answers and you solve your problems. Okay, so when solving a system in three variables, you're going to use methods that we've talked about before, and that is substitution or elimination. And you're going to reduce the system to two variables, and then you're going to continue just like you did when you had two variables. So let's go do I have 1A or 1B. I don't have anybody in here telling me which one. Um, let's go with 1A. So when you're looking at that, you got to remember that you're going to combine two pairs of equations. So I generally think of them as A, B, and C. And you want to combine two pairs such that the same variable falls out when you do. Okay? If you have one like this Z here, you could solve it for Z and then plug it back into both of those. People generally tend to make more mistakes with substitution than elimination, so I kind of shy away from that. But the fact that I do have one with a Z like this, I am going to take advantage of that and multiply it by 2 to combine it with this one. So my first pair, let's go talk about this. If this is, let's call this one A, this one B, and this one C. So if I'm going to combine B and C together, so I'll write it like this just to kind of make it easy to follow my work. Okay, so B, of course, is negative 3x plus 5y plus 2z equals negative 27. And remember this one, to make my z's fall out, I'm going to have to multiply this equation by 2. So negative 5 times 2, 3 times 2, negative 1 times 2, and then negative 17 times 2. And that, of course, gives me negative 34. Okay, so I'm going to combine these two. Negative 3 and negative 10 give me negative 13x. 5 plus 6 is 11y. I also like to add. You can, of course, subtract, but a lot of people, again, make mistakes when they're subtracting. So that's why I choose to find opposite signs. And then 27 and 34 gives me negative 61. So I have two of them. I have an equation now with two variables. So now I need to combine another pair. So this time I'm going to combine A and C. And So A is 2x plus 4y minus 5z equals 18. And to combine c with that and to make it fall out, this time I'm going to have to multiply it by negative 5. So negative 5 times negative 5 is 25x. Negative 5 times positive 3 is negative 15y. And negative 5 times negative 1 is positive 5z. And negative 5 times 17 is 85. So I'm going to add those together. 2 plus 25 is 27x. 4 minus 15 is minus 11y. Ooh, look at that, they're opposites. Sorry. And then 18 plus 85 is 103. Okay. Okay, sorry about that little interruption. Okay, so now I have two equations, two variables, and I'm going to combine these two. Okay, so when I combine them, negative 13 plus 27 is 14x. My 11y and negative 11y cancel, and then 103 and negative 61 give me 42. So then you know that x equals 3. So I have x equals 3. And once I have that go into either equation, you want to go into the one that has two variables. So again, pick either one. I'm going to pick the one that has a positive y value because, again, people tend to make mistakes with that. So negative 13 times 3 plus 11y equals negative 61. That's negative 39. So we have negative 61 plus 39 means that 11y equals negative 22. That, of course, tells me that y equals negative 2. And now to finish that up, we need to go to find out what z is. So pick any one. I'm going to pick the one, I mean, it's got a negative, yeah, but then I don't have to divide anything at the end. So I'm going to go ahead and use this one. And that gives me negative 5 times my x value plus 3 times my y value minus z equals negative 17. So negative 15 minus 5 is negative 20. So this is, I mean, that's 6. Negative 21 minus z equals negative 17. So negative z equals 4, which means that z equals negative 4. Okay, so my answer as an ordered triple should be x, y, and z. And just like everything else that we've talked about, okay, to find the third one, I put it into this equation. So you can check easily into the other ones. 6 minus 8 is negative 2, and negative 2 plus 20 is 18, so that one checks out. Negative 9 minus 10 is negative 19, and negative 19 minus 8 is negative 27. So I know that all those have checked out. Okay, so the other example that I do, I didn't do that other example in there. If you want me to do another one, please come see me, but I think y'all probably want me to move on. So we do have some other systems that we need to look at. Negative 4x minus 2y minus z. I'm actually going to do both of those, but when you look at that and try to figure out which variable, I'm going to notice that 2 goes into 12 and 4 goes into 12. So when I combine these, okay, let's go with A, B, and C again. Actually, the bell's fixing to ring, so I'm going to have to stop this one, and I'll pick up in a bit. Okay, so continue with A. I'm going to combine A and B, and actually, if you look at that, so if I wrote down B, let's write down that I'm going to do A and B together. B is 12x plus 6y plus 3z equals 45. And then I'm going to take A and multiply it by 3. So I'm going to have negative 12x minus 6y minus 3z times 3 equals 45. So once you notice that everything on this side falls out, but that side did not, then that of course leaves me with an answer of no solution. Okay, because I got a false statement. All right, so let's go look at 2b in another situation that might come up. Again, A, B, and C. So I'm going to combine, I'm looking at my x's and my y's. My z's look like the easiest to make to fall out. So first I'm going to combine A and C because that looks pretty straightforward. So 3 minus 14 is negative 11x. 5 minus 17 is negative 12y. My z's fall out, and 13 minus 19 is negative 6. So now let's go with, I like the ones that have opposite signs, so I'm going to choose B and C. B is not going to change, so I'm going to go ahead and write that. Negative 5x minus 2y minus 4z equals 20. I have 2, I need 4, so I'm going to multiply everything here by 2. So that gives me negative 28x minus 34y multiplied by 2. So then plus 4z equals 19 times 2 is negative 58. Having a hard time writing. I've been on spring break because it's not 58, it's 38. Where are my people? Negative 38. Okay, so when I combine these, negative 5, negative 28 is negative 33x minus 36y. My z's fall out. 20 minus 38 is negative 18. I notice they all have a common 3, so I'm going to divide everything by 3, which is going to give me negative 11x minus 12y equals negative 6. Well, hopefully you notice these two are the same. So since they are the same, then if you can think back to our pictures, that's telling us that there's going to be an infinite number of solutions. Okay, infinitely many solutions. Now the directions say to solve. Are you solving it if you tell me there's infinitely many solutions? No, you just tell me how many they are. So what I'd really like for you to do is when you come up with the same line like that, the solutions are any ordered triple x, y, z such that, and then write the equation of that line, and you can simplify it. I don't want to put the negative, so I'm going to put 11x plus 12y equals 6. So any ordered pair x and y that satisfies that equation with any number for z will be the answer. Okay. As I said, your book's just going to say infinitely many solutions. Um, I would really like for y'all to write that just because it's good for you to understand that concept. Okay, last one, a word problem, because that's very appropriate for these types of problems. Ms. Garza invested $50,000 in 3 different accounts. She invested 3 times as much money in an account that paid 8% interest than an account that paid 10% interest. The third account earned 12%. If she earned a total of $51.60 in interest each in a year, how much did she invest in each account? So basically, I'm going to have an X, a Y, and a Z. And that's the amount of money that I'm investing in each one. And the total amount of money that I invested is 50,000. She told me that the amount that I put in 8%, the amount in the 8% is 3 times the amount I put in 10%, and the interest, which is that's not a 0, 0.08x plus 0.1y plus 0.12z gives me a total of 5160. And I'm going to go ahead and simplify that one, get rid of those decimals, and that gives me 8x plus 10y plus 12z equals 5160 with 2 zeros added on. Okay, So now we have our three equations and our three unknowns, and we're going to solve. And this is kind of a good example for substitution. So what I'm going to do is I'm going to take that 3y and I'm put it in here for x, and I'm going to put it in there for x. And the two resulting equations, 3y plus y, of course, is 4y plus z equals 50,000. And then 8 times 3y is 24y plus 10y gives me 34y plus 12z equals 516000. So I have two equations, two unknowns. I'm going to take this top one and I'm going to multiply it. A really bad looking arrow, but that's what that's supposed to be. I'm going to multiply it by negative 12, so my z's will fall out. So that gives me negative 48y minus 12z equals negative 600,000. So when I add those and my z's fall out, I'm going to end up with 34 minus 48, which is negative 14y equals negative 84,000. And divide both sides by negative 14, and you're going to get that y equals 6,000. So if y equals 6,000, then that means that x equals 3 times that, so x is 18,000. And then your z, I'm going to say, of course, is 18,000. Oops, forgot a zero there. 18,000 plus 6,000 plus z equals 50,000. So you can figure out that z equals 26,000. So to answer the question, we're going to say that how much did she invest in each account? So uh, she invested 18,000 at 8%. She invested 6,000 at 10%, and she invested 26,000 at 12%. And yes, it'd be nice to have that much money to invest. Okay, so that's solving three equations, three unknowns. If you have any question, please come see me.